Okay, for the fourth subtopic, we're going to have inverse function or fungsi songsang. So let's see the definition of inverse function. Let's say what we have over here. Inverse function, if fx given fx equal to y is a function that maps x to y, then the inverse function is denoted by f to the power of -1. This is how we write down the inverse function of f, where f inverse is a function that maps y back to x. So f inverse x equal to y, read as f inverse of x. Originally we have this one, fx equal to y. So this is this, fx equal to y. For the inverse function, you will have it will maps the y back to x. So dia akan patah balik y ke x. So originally, when we see this diagram, you have x value over here, or your domain, and you have y values, which is your range or your output, right? So when we for a function, we start with the values, we substitute into a function f, then you get an output or y or the range. But for inverse function, it is vice versa, terbalik. So it will start from y, then we insert or we substitute the y into the function, which is the inverse function, then you get x. So dia berpatah balik lah. That's why we call it as inverse function, and it is denoted as f to the power of -1. But this one is not equal to 1 over fx. Okay, please take note of this. Okay, suppose we have fx equal to y. Then for f inverse y equal to x. This is how we write down the inverse. This is the original function and this is the inverse. Okay, for the domain of original function f, the domain of function equal to the range of the inverse function. And the range of the normal function or the original function is equal to the domain of the inverse function. It is actually terbalik, inverse, right? So it is quite similar to the one in this diagram. So x is actually your domain, y is your range. But now it is vice versa. Okay, dia sebaliknya pula. So y become your domain and x become your range. That's why you get this thing. Dia terbalik. Domain function, this one is range for inverse. Okay. An inverse function of f exists only if the function f is a one-to-one function. So this is what we have learned previously. For a function, it must be one-to-one or many-to-one relation. So it same goes to an inverse function, but for inverse function, we only consider one-to-one function. Okay, then method to test whether a function is one-to-one is the first one. We're going to use algebraic approach. We're going to test whether it is one-to-one. To make sure if it is one-to-one, then it will have an inverse function. So let's say if we have fx1 function 1 equal to fx2, then x1 equal to x2. Okay, that one is using algebraic approach when you have two functions. So you're going to make sure the left-hand side, the function on your left-hand side will be the same with the function you have on the right-hand side. Then the x1 is equal to x2. Okay, the second approach is using a horizontal line test. Okay, this is actually graphical approach. You need to sketch your graph. If the horizontal line intersect the graph of the function only once, then the function is one-to-one 1. Remember what we have learned before? We have vertical line test, right? Or we call it as pencil test. That one is to check whether the graph is a function or not. But this one, horizontal line test, is to check whether this graph will have whether this graph has it inverse or not. Okay, so how to check is you have to first of course you need to have your curve, okay, your graph. Then we draw a horizontal line over there. If the line cuts only one point or intersect atau bertindih ataupun potong curve tu sekali sahaja, which mean that it is a one-to-one function. So the horizontal line intersect the graph at one point, which means that this graph will have an inverse function. And how about this? When you draw a horizontal line, it cuts through 2 points over here and one over here. So this is intersect the graph at 2 points, which means this is not a one-to-one function. So this graph or this function will not have an inverse function, not one-to-one, and this is one-to-one. Okay, now changing the independent variable, composition of inverse function. How are we going to compose our inverse function? So in general, we have function of inverse function n equal to n. And this one, if this is quite similar, just that this one, the f is outside. Now the f is inside. The f inverse is outside. Is equal to n, assuming both f and f inverse are defined for n. Okay, let's see the example. Consider fx equal to x cubed. And this inverse function equal to this one. So let's say we have x equal to 3. We're going to substitute x equal to 3. So when x equal to 3, this function become 27. We substitute 3 into this. So 3 to the power of 3, you get 27. And for f inverse, for 27, f inverse for 27, we take back the answer we have just now. For the inverse, you will get 3. When you put it into, you substitute the value x over here with 27, kita cari punca kuasa 3 dia, you akan dapat the answer as 3. So, thus, f inverse for 27, you will get 27 again. And f inverse for f3, you will get 3. Okay, so this is what it means by this formula and this formula. Okay, whatever you have, when we multiply the original one, the original function with the inverse function, you will get n. And whenever you change it the other side or the other way, you will get also the similar answer. Now we're going to see method of finding the inverse function. So there are two ways of finding the inverse function. First one is using formula, which is this formula. F multiplied with f inverse equal to x. This is f, the original one. This is the inverse one. So you'll get x. And the second one is by using substitution method. So let's see, not there. Number 1. F inverse and then to the power of -1, ataupun you inversekan lagi dia sekali. F inverse, when you inversekan lagi sekali, you will get the original function. Okay. The other one is F inverse, you multiply with the original function, you will get x. X will be any value. And F multiply with f inverse, also you will get x over there. So this is actually from the previous slide. The number 2 is from the previous slide. whenever you change the position of f inverse and the original f, you'll get the answer, the same answer, which is x. And the third one, this is, remember, this is not O, okay? This is actually a symbol of composite function from what we have learned in the second subtopic. F dot G, composite function inverse, then you get G inverse composite function of F inverse. Okay, this is how you write down when you have composite function and then it is inverse. Let's see more example. Given fx, you have original function. You need to find the inverse of it. So how do you find? This one we're going to use the formula. So previously I mentioned we have two ways, whether you want to use formula or you want to use substitution. So I use formula first. So we use this formula, f times f inverse, you get x. So what you have is 4. And then you get f inverse minus 3. Okay, so this means that, I'm sorry, this is not a multiplication. Okay, this is actually, you're going to substitute this value into this. Okay, so f inverse equal to x, which means that any value of fx over here, you're going to substitute with the f inverse. Okay, originally we have fx, so now this x you're going to substitute with the inverse. Just write it down as f inverse x. So now you have 4, just write it down as 4. This x value we're going to substitute with f inverse x, the f inverse, where we still don't know what is the inverse function. Okay, and then 3 just minus 3, and then this one is equal to x. So now you can rearrange this position. You can bring this whole thing, the denominator, on the to the right hand side, so you get this thing. Then you can rearrange it. Just leave the inverse function on the left hand side, the rest you can bring it on the right hand side. Pindah-pindahkan dia until you get this answer. So this is the final answer, f inverse. Okay, or inverse function of x equal to this. This is using formula. So again, this is not a multiplication. This is actually f inverse. You're going to substitute into f. Macam yang saya cakap sebelum ni. Sebutan yang dekat belakang ni, the term at the back, that the one you're going to substitute into the f. Okay, example 17. Find the inverse for each of the following function. Okay, we'll see for a, fx equal to 2x minus 1. For x is element of real numbers. And this is for b. Let's solve it one by one. For a, so we are going to use a formula there. f inverse equal to x. So we're going to substitute this inverse function into x, into f there. So you have originally 2x minus 1. Now this x, we're going to substitute it with f negative, not f negative 1. This is, we're going to substitute x with inverse function. And then negative 1 or minus 1, you just write it down again. Okay. So you have, there you have f inverse negative 1 equal to x, and then you just rearrange it. Susun semula until you get the inverse function is actually equal to x plus 1 divided by 2. Okay, then for the second one, again we're going to use the same formula. So f inverse equal to x. Now we're going to let the f inverse as y, because we don't want to write it down in this way. It's quite confusing, right? So you got, why don't we let this one, instead of using this f inverse negative x, f inverse x, this is quite tedious. So why don't we write it down in this form? Just let it as y. So now you will have fy. Okay, let me This is actually this one. So this one dia dah ganti dengan y. This is y. So dia tulis semula fy equal to x. So now why don't you have this original function? So you're going to substitute the term of x with with y. So semua yang x dekat sini akan bertukar jadi y. That's why you have this one. Okay. So you have y cubed plus 2 over 3, and then this is just follow x. Okay. So now you just bring this one 2 over 3 to the right hand side, it become minus. Then kita ada kuasa 3, you bawa pindah ke sebelah, dia become punca kuasa 3. So don't forget to change back this y. This y is actually your f inverse. Because at first we let this one, kan? Because we don't want to write it down macam ni. Nanti you akan confused sebab panjang sangat. That's why we just substitute it with simple one, y. So you get this answer. Okay, more example. This one is using substitution. Given fx equal to negative 2x minus 7. So now we're going to let this fx equal to y. We're going to let this one as y. Okay, by substitution. This one is different from the previous one. So y, now you will have y equal to negative 2x minus 7. We're going to solve for x. Okay, so kita mau pindahkan x tu, sebutan x tu di sebelah kiri. So the rest, we only have single x over here. So bila you rearrange, susun semula, you will get x equal to negative y minus 7 divided by 2 from here. I just rearrange it. So you get this one. Now you have this x, right? So for the inverse one, for the inverse of y, so you have this one. Negative y minus 7 divided by 2. Okay? So you just substitute it with y. This one, you just substitute it with this one. So you get negative y, negative 7, minus 7 over 2. Okay, that one is in term of y. In term of y. But we want our answer to be in inverse function of x. This one is inverse function of y. Because we originally have function of x. So of course you want to find inverse function of f. So you just need to change back the y over here, become x. Okay, that is the answer. This is using substitution. Okay, this is the last part of our chapter 1, which is subtopic 1.5, exponential and logarithmic function. Exponential and logarithmic function. So these two functions is classified as transcendental function. So what is transcendental function? A transcendental function is a function which does not satisfy a polynomial equation. Okay, wait, I can't see my cursor. Okay, a transcendental function is a function which does not satisfy a polynomial equation whose coefficients are themselves polynomial. Itulah maksud dia. Dia untuk transcendental, dia tidak boleh memenuhi polynomial equation. A function which is not transcendental is said to be algebraic. Sebabnya tadi polynomial equation ni actually adalah algebraic. Tu yang dia kata kalau function tu bukan transcendental means dia adalah algebraic. Okay, the logarithm and the exponential function are example of transcendental function. And the transcendental function also is a term often used to describe trigonometric and hyperbolic function. Okay, so this is exponential and logarithm function. Consider the exponential function y equal to 10 to the power of x. This is exponential function. Bila you ada to the power of x. Kalau polynomial, we have like x to the power of 2, 3 and so on. X tu yang ada power. But now for exponential, the power is actually X. Okay. Based on that function, declare a new function, logarithm function. Okay, based from this function, we're going to declare a new function, which is, we call it as logarithm function. So, ini dan ini actually are the same. But the way we write it down, differentiate whether it's exponential function or logarithm function. When you have this kind of simple, it is an exponential function. When you have in term of x equal to log base 10, y, this one is in term logarithm. You should be able to see that these are inverse function. Yes, this is actually inverse function. Okay, dia actually benda yang sama, cuma dia cara penulisan tu berbeza. Okay, in general, originally you have this one, right? Exponential a equal to b to the power of x. Yang mana bila you inversekan dia atau patah balikkan dia, dia akan jadi macam ni. Log a base b, ni kita panggil base dia. 10 ni is a base yang kecil ni. B ni also a base. Log a base b equal to x. So yang x tadi tu, yang kecil ni dia jadi besar. Yang ni yang besar ni akan jadi kecil. So itulah exponential and logarithm. Dia saling berkait. Actually it is an inverse function. Okay, so the log of a number is an exponent. So the log of a number is an exponent. Ni hasil log tu adalah exponent dekat sini kalau exponential function. This one. So this is how the graph of log and exponential. Kan kita tengok kalau inverse function dia simetri bila dekat paksi y equal to x. Dia simetri dekat y equal to x. Paksi x, y equal to x. So you have this one is exponential. Y equal to b to the power of x. So you have this kind of graph. Now you have another curve which is this. Y equal to log x base b. This is logarithm. So when you fall a paper based about y equal to x axis, you akan dapat benda yang sama, curve yang sama. That's why we say it as symmetric about the y equal to x line. Okay. So correspondent. This is correspondent between properties of logarithmic and exponential function. So you're going to see the difference. Don't get confused. Even though these two are quite the same. Property of exponential, b to the power of x. This one is property of log. Log x base b. So when b to the power of 0, you'll get 1. Anything exponent 0, you get 1. B to the power of 1, you just get b. But for this one, you see log 1 base b, you get 0. Anything you log 1, you get 0. Anything you get log b base b, the same, this one is the same, you get 1. And then this is the range. The range is from 0 until positive infinity. The domain is this. But remember, if these two is actually inverse function. So the domain and the range will be terbalik. Okay. So this range become a domain for log. But this domain for exponential become range for log. So dia terbalik saja. This one is this, this one is this. Okay. And axis is a horizontal asymptote, while axis is vertical asymptote. Okay, so you have this kind of log bx to the power of x equal to x. Why is it so? Because bila you ada exponential ni, you boleh bawa dia dekat depan. So you write it down as x. So yang tinggal cuma log bb. Log bb, actually you get 1. That's why yang tinggal cuma x times 1. You get x over there. Okay, and for all real values of x. And this one, when you have b to the power of log bx, you will get x again. So bila ni sama, you akan dapat yang ini semula. Okay, and for this one, ln exponent x, you will get x. And exponent ln x, you will get x. Okay, what is ln over here? Ln over here is actually log base e. Okay, that's why we call it as ln. Biasanya kalau log ni yang kita selalu sebut, this is actually log base 10. But for ln, you will have log base e. That's the difference, log and ln. Okay, so you will have exponent ln x, you get back x. So these are the properties of logarithms. Theorem, this is algebraic properties of logarithms. The first one, log AC base B. This one, you can, this one is multiplication, right? Hasil darab. You can write it down using this one. This is a product property, hasil darab. So you can decompose dia, tulis semula dalam bentuk macam ni. Log A plus log C. Dengan syarat dia punya base mesti sama, B and B. Okay, the other one is quotient property, hasil bahagi. Log A over C is actually, you can write it down using log A minus log C. So the divide become minus. Dengan syarat B itu mesti base dia mesti sama. And log A to the power of R base B. Remember, if you have exponential over here, you can bring it at the front. Bawa dia tulis dekat depan. That's why you have R log B base A, power property. Kalau ada power dekat sini, bawa dia dekat depan. And then you have log 1 over C, 1 over C. So kalau 1 over, maksudnya ada negatif dekat depan. Negatif log C. This is reciprocal property. So sama juga macam kita buat 1 over 2. This one we can write it down as 2 to the power of negative 1. This is actually the same. Lebih kurang reciprocal. Then we have common and natural base. Common and natural base. Usually we use base 10 or another base called E. Base 10 is a common base. That one is log base 10. Okay, ataupun kita panggil juga sebagai yang kita sebut selalu dalam kalkulator log sahaja. But for this one, base E is natural base. So this one is actually ln, which is equal to log base E. Okay, so I hope you can differentiate between these two. Then we have natural exponential. So natural exponential, you have these two graphs. Consider function fx equal to a times exponent kx. Assume a greater than 0. So a ni is a constant that is greater than 0. E is exponential kx. So if k greater than 0, you get a graph like this, increase. If k less than 0, exponent negative, meaning that you have exponent of negative x, you get decreasing graph like this. Okay. That one is natural exponential. This one for natural logarithms. We have used base of 10 for log. Another commonly used base for log is E. Okay? E is an irrational number. Irrational number maksudnya yang tidak boleh ditulis dalam bentuk pecahan. Okay, S is pi. Okay, sorry, this one should be in here. Lari sedikit. S is pi. Okay, consider fx equal to ln x. So this is how the graph look like, ln x. And then we have properties of the natural logarithm. Recall that y equal to ln x. So x equal to exponent y. Ini adalah macam mana kita tukar dia tadi. Okay, y equal to ln x, x actually equal to exponent y. Okay, not that. Ln 1 equal to 0 and ln x exponent equal to 1. This is very important. Ln e atau ln exponent equal to 0. Why is it so? Because you have ln is actually log base e. Log base e and then you have e again equal to 1. Bila kita ada satu ni sama dengan ni, so it's become 1, okay? And ln 1 equal to 0. And then you have ln time dengan exponent x, of course you will get x sahaja. Kenapa? Sebab you have like this. Ln is actually log base e, right? So you multiply with exponent x. This x you can bring it at the front. So you will get x log e and e. But this one is actually equal to 1. That's why x times 1, you get x only for this one. And this is exponent ln x equal to x. Bila exponent bertemu ln, dia akan cancel out. Yang tinggal cuma x saja. Sama juga, bila ln bertemu exponent, yang tinggal hanya x saja. Okay. Then you have ln. This is another properties. Ln a multiply ln b, you get ln a plus ln b. Macam log punya juga sama. Okay, it's similar with the log properties just now. When you have product, you kena tulis as tambah. When you have quotient ataupun hasil bahagi, you guna minus. When you have power over there, power rules, you bring this power at the front. Bawa power ni ke depan. So you get this one. So there is few misconception about log. So be careful. Log a plus b is not equal to log a plus log b. We cannot write it down as this one. This is wrong. This is totally wrong. And log a minus b is not equal to log a minus log b. And log a multiply b is not log a times log b. This is totally wrong, not the same. Okay, log a divided by log b, not this one. This one should be log a minus log b, right? We learned it just now. Log a minus log b. This is how it should be. And log 1 over a is not equal to 1 over log a. Okay? Let's see the first example for the logarithm function. Now we have natural log. Given function fx equal to ln 3x plus 2. So first you need to find inverse function. So it's up to you whether you want to use formula or substitution method. And then for b, determine the domain and range of the original function and the inverse function. And then last but not least, you need to sketch the graph of fx and f inverse on the same axis. So let's see the solution. Okay, knowing that fx is this, we are given this one. So now I'm using when let y, meaning that let ni, kalau ada let y ni, meaning I'm using the substitution method. So let y equal to ln this one. So I just let this one as y. Okay, y equal to ln 3x plus 2. So this ln is actually log base e. I write it down using this one, log base e so that I can change it into exponential later on. So now you have 3x plus 2. Bila kita ada dalam bentuk log macam ni, bila you want to change it into exponential, so this one, yang ni akan kekal besar, 3x plus 2. Yang kecil ni akan jadi besar. Dan yang besar sebelah sini akan jadi power dia. Okay. So you have 3x. This is all in log form. This is in exponential form. Exponential. This is exponential, okay? Okay, then after I get this is much easier to solve rather than you use the log form. So after I get this, I rearrange because I only want single x on the left hand side. Susun semula. The rest you bawa pindah ke sebelah. So you get x equal to exponent y minus 2 divided by 3. So this is in term of x, kan? So this answer in term of y. So you want the final answer to be in term of x. So you just rewrite it again. The inverse function of x is actually equal to exponent y. This y tukar kepada exponent x minus 2 divided by 3. So you get the inverse function of x. Next, you have to determine the domain and the range of the inverse function and the original function. So in here you have 3x plus 2. Ln, you must have a positive number which is greater than 0. So 3x plus 2 must be greater than 0. You have x, the rest you bring it on this side. X must be greater than negative 2 over 3. So remember, x is actually our domain. Our domain. X value, remember, x value is our domain. So the function is defined for x greater than negative 2 over 3. This one is for the original one. Maksudnya, function tu cuma boleh can be defined, cuma boleh function tu cuma bererti kalau x tu lebih besar daripada negatif 2 per 3. So the domain for the original function d small letter f over here start with negative 2 over 3. This is open bracket. Okay. Maksudnya dia kena lebih besar daripada negative 2 over 3. We don't write it down using a close bracket. This one is close bracket. Close bracket mean 2 per 3 tu termasuk. But now it must be greater than 2 over 3 itu is not included. It must be greater than this until positive infinity. So it can be any value from this range. And how about the range? The range will be the y values. Okay? The y values. Bila you substitute the value of x into the function, you will get an output, right? The output is actually the y values. This is the output. So the range will be from negative infinity until positive infinity. So how do you determine your domain and range for inverse function? You just terbalikkan dia saja. So for domain untuk inverse function, you take this one. And for range, you take this one. For range, you ambil yang domain. Dia terbalik saja. Okay, last but not least, you need to sketch the graph, of course, for the function, the original function, and the inverse function. This is the original function, ln 3x plus 2. So this is the border or the that you cannot touch. The graph, the asymptote yang kita tidak boleh sentuh. Graph tu tidak boleh sentuh negative 2 over 3 sebab kita kata tadi x must be greater than negative 2 over 3. Okay, so see the graph does not touch this line. Okay, next you need to draw your y equal to x. Garis y equal to x, this one. Okay, so dia adalah simetri kepada yang ini. Bila kita lipat, you will get the other graph on this side, sebelah bawah ni. So, you will get this one. Bila you ada satu sebelah sini, satu lagi you kena cari lagi negative 2/3 yang sebelah sini juga. So you get this one, the blue curve as your inverse function. So of course the inverse function pun tidak akan sentuh negative 2/3. Yang tadi original function dia tidak sentuh 2/3 yang ini. Now the inverse function, the blue curve, dia tidak sentuh yang negative 2/3 yang this one, yang horizontal. So this is how you sketch your original function and of course your inverse function. And don't forget to draw your symmetry line, which is y equal to x. Okay, that's all for the exponential and logarithmic function. Thank you.